Hi everybody, I hope you're doing well. The purpose of this video is to help you on your quiz that I just posted on Google Classroom. Some of you were absent on Friday, March 13th and weren't able to take that Chapter 18 quiz. So I made this little video to help review some of that material, and we're going to get started. If you want, you can go ahead and pause the video now, read the problem, try it on your own. But we're going to construct a 90% confidence interval for the true percentage of 12th grade students who are planning to go to a 4-year university or college next fall. So in this problem, it says that I gave a survey to my statistics classes, and 25 students took the survey, and 18 of them indicated that they plan on attending a 4-year university or college in the fall of next year. Use this information to create a 90% confidence interval for the true proportion of 12th grade students at Rush who plan on attending a 4-year university or college in the fall of 2020. First step, what is p-hat? Remember, p-hat just refers to the sample proportion. In this case, we had 18 students indicate that they plan on attending a 4-year university out of the 25 students who took the survey. So we're just going to do 18 out of 25 to get our p-hat, our sample proportion. And that's 72%. So the answer for step 1 is 72%. What is q-hat? Well, remember, that's just the complement of p-hat. So we're just going to do 1 minus 0.72 to get q-hat, and that's 28%. Alright, what is the standard error? So the formula for the standard error of a sample proportion is equal to this. Standard error of p-hat is equal to the square root of p-hat times q-hat divided by n. So we're going to do the square root of 0.72 multiplied by 0.28 divided by 25. And we get that our standard error is equal to 0.0898 if we round it to 4 decimal places. Standard error of p-hat is equal to 0.0898. So we have our answer to step 3. Alright, and the z-score, or a critical value for a 90% confidence interval, we can refer back to that one handout that we received. The z-scores for the confidence intervals, here they are. Oops. Go back to my clipboard here. Here are the z-scores that correspond to the various confidence levels. So this question is asking us, what is the z-score or the critical value for a 90% confidence interval? Well, that's right here. It's 1.645. And we're going to use that for step 5 when we create our 90% confidence interval. So one of the things we learned is that you can do this very easily on this calculator by using it's just stat. So we go to stat, we go over the test, and we go over to 1 proportion z interval. And x is the number of successful trials, in this case the number of people that indicated that they planned on going to a 4-year university. N is our sample size, in this case 25 students took the survey. Our specified confidence level is 90%. We hit calculate, and it gives us our confidence interval. And we can see that if we round this to, change it to percents and round it to 1 decimal place, it would be 57.2 and 86.8%. So we're going to select answer choice D. Now let's say you don't want to use that method, or you don't have this type of calculator. You could use the formula for a confidence interval, which is this. Confidence interval is equal to p-hat plus or minus the z-score that's associated with your specified level of confidence multiplied by the standard error. So I'm going to use that method now. So our p hat is 72% plus the z-score, 1.645, multiplied by our standard error, 0.0898. And this is going to give us the upper endpoint of our confidence interval. If we want the lower endpoint, we're just going to do minus that. So it's plus or minus. We have to do minus separately. And again, we get the same answer. We have 57.2 and 86.8. So our confidence interval, 57.2% and 86.8%. Alright, so what does this actually mean? I'm going to go back to my clipboard here. I wrote up some things about what this means. So this means that we're 90% confident that the true proportion of students that will attend a four-year college is between 57.2 and 86.8%. And back to what that 90% confidence means, that means that 90% of samples of this size would yield confidence intervals that capture the true proportion of students that plan on attending a four-year university next fall. So we saw this when we did the marble experiment in our class. We wanted a 90% confidence interval, and that meant that we were okay with 10% of the time not capturing the true proportion of those marbles that were clear. Or blue, I can't remember which one we did. So this is how you find the confidence interval. And our question 7 is, what is the margin of error? Well, the margin of error can be found just by subtracting those two confidence level endpoints and dividing by 2. The margin of error describes how far on either side of p hat our confidence interval extends. So the total length of our confidence interval is 29.6%. So our p hat is centered at 72%, plus or minus 14.8%. So if you want to think about it like this, the margin of error is this part of the confidence interval formula. It's just the z-score multiplied by the standard error. That's another way you can do it. So we could simply take our 1.645 and multiply it by that 0.0898. And that should give us the same number, 14.8 if you round it, right? So our margin of error in this case is 14.8%. Try to be consistent here. And our last question on this practice quiz, assuming that p hat remains the same, how many students will we have to sample in order to reduce the margin of error for the 90% confidence interval to less than 8%? So right now our margin of error is 14.8%. Maybe that's too high, and we want to take this confidence interval and actually kind of make it more narrow to zone in on the true proportion of students that are planning to attend a university in the fall. So what we're going to do, we can do this two ways. We're going to start out first by just thinking about what is margin of error. Well, it's this green thing right here. So the margin of error is equal to the z-score multiplied by the standard error. In this case, we want our margin of error to be 8%, so I'm going to actually set my margin of error to be 8%. And we know the z-score associated with a 90% confidence interval is 1.645. So I'm going to set that at 1.645. And our standard error, we're going to assume that, this is actually dependent on our sample size, so we have to use the standard error formula here. So standard error is the square root of p hat multiplied by q hat divided by n. So if we can solve for n, we'll have the sample size necessary to achieve this margin of error. And we actually want to have the margin of error be less than 8%. Let's change this to a less than symbol reading from the right side. So this is saying that our margin of error is going to be smaller than 8%. So I guess I will begin this by first dividing by that 1.645 on both sides to get rid of it. So 0.08 divided by 1.645 is 0.0486 if you round it, 0.0486. So now, if we want to get rid of the square root, we can take each side and square it. So I'm just going to square each side of this equation to get rid of our square root. And I'm going to use the rounded form of that 0.0486. Squared. 0.00236. So there is a little bit of round off error that I'm carrying here, but that's fine with me. I don't feel like writing out all those decimal places. 0.00236. And the numerator of that fraction, 0.72 multiplied by 0.18, I'm going to go ahead and multiply those out. Actually, that 0.18 should be a 0.28. That would have been a problem. I'm going to go ahead and fix that now. So that 0.18 here should say 0.28. That's what Q was. All right, 0.72 multiplied by 0.28. 0.2016. And n is in the denominator. So now to bring n into the numerator, we can multiply both sides by n. Multiplying by n here. Multiplying by n here. My n's are going to cancel. And then to solve this equation, 0.00236 n is equal to 0.2016. We're going to divide both sides by 0.00236, and we have n is equal to 85.4. This symbol here, since we never divided or multiplied by a negative, is still a less than symbol. It's going this way. So this says that n has to be greater than 85.4 to achieve a margin of error less than 8%. So the first whole number that's greater than 85.4 is 86. So I'm going to select 86 as my answer. And that's how many people we would have to survey in order to achieve that margin of error. There is an easier way to do this. It's sort of a generalized result of the math that I just did here. And I have that stored in my clipboard here. Let me get that back. This formula. So we can use this formula whenever we're given a margin of error that we need to achieve. And we need to find the sample size in order to achieve that. It actually is the exact same calculation that we did here, but it's plugged into a nice, easy-to-use formula. So PQ times Z squared, Z being the critical value associated with our confidence level. Since we were talking about a 90% confidence level, we're going to use this as our Z value. The margin of error that we were trying to achieve is 8% margin of error, and this will give us our sample size. If I could adjust this formula a little bit, I would say that this should be a greater than symbol. You always have to round up here because the margin of error that we're required to achieve, it usually says we need a margin of error to be less than that percent. Alright, so I'm just going to use my fraction bar, type this in exactly how it looks on my screen. 0.72 multiplied by 0.28 multiplied by 1.645 squared divided by 0.08 squared, and we should get around the same result that I have above this, that 85.4. Let's see how close we get. 85.239. So this is the exact result. It's a little bit different than the previous result by a couple tenths, and that's due to the round-off error that was incurred over here when we rounded a few times. But we still end up with the same answer, so we want the first whole number that's greater than 85.239, or 0.24 if I round it, and that would be 86. So if we survey about 86 people, we could achieve that margin of error. Alright, so you're going to complete the quiz. Looks exactly like this, the first 7 questions. This should be really helpful. I put some extra credit on there to help you get a better grade. Try your best on those. Some of them are very straightforward. Some are a little bit more challenging that really require you to read Chapter 18 carefully. But you can go ahead and try them. If you get them wrong, they can't hurt you. Good luck, and feel free to reach out with any questions via email or Google Classroom, and I look forward to hearing from you. Thank you for watching.